Hello guys, today actually I'm going to discuss a little bit about the spherical mirror usually we study in high school. You can see here the two spheres. So actually these are sphere because but we have a 2D diagram, that is why it seems like a circle here. So these are two spheres, okay. So we consider these two spheres before to start the spherical mirrors. If we cut these spheres into two parts, okay, then we will have two spherical mirrors. This part, this part, this part, and this part. If we polish the inner surface of the sphere, then the light will be reflecting from the outer surface here in this case. Other possibility, if we polish the outer surface of the sphere, then the light will be reflecting from the inner surface. When the light will be reflecting from the inner surface and the outer surface is polished, we call it concave mirror. Other case, when the inner surface is polished and the light is reflecting from the outer surface, we call it convex mirror. Okay, these two things. And some you can see here, C is the center of the sphere, R is the radius. Okay, we can call it radius of curvature. These are axes. And P is pole. Okay, so these are some things. Now, in the next slide, actually, what we'll study about the rules of image formation, or how to draw the rays. Here, what do you see in case of, and this is the first rule in general. I mean, I'm trying to explain in a very simple way. What do you see here? Outer surface is polished, so light is reflecting from the inner surface, so it means it's concave mirror. So what first rule is saying, if the incident ray or the light is coming parallel to the principal axis, this is principal axis, this is pole. So incident light is coming parallel to the principal axis, then it will appear to pass through F. What is F? F is the focal point. Incident light here, and it appears to pass through the F here. So intersecting here, both these lights, and this is the focal point. So this was the first rule of image formation. This thing simply is showing that the angle of incident ray is equal to the angle of reflected ray. Now, if we move to the second rule, what it shows, if the incident ray is passing through the focal point, or passing through the F, then the reflected ray will follow this path, which is parallel to the principal axis, So this here, C is the center of the curvature. Okay. So this is the second rule. What it tells, that when the incident ray is passing through the F, so the reflected one will follow the path parallel to the principal axis. Now we move to the third rule. What third rule is saying, if the incident ray is passing through the C, definitely it will be reflecting and is retracing the same path. So incident and the reflected one. So incident ray, which is passing through C, it retraces its path and it will pass through the C. It's retracing its path. This is the third rule. Now we move to the fourth one. This fourth rule, what it tells, that this is, as I told you, this is a pole. This is the F focal point here. So the angle of incident, this is angle of incident, this is angle of reflection, reflected ray. So both these angles are equal at the pole of the spherical mirror. Here you can say angle of incident equal to angle of reflection, or incident ray angle is equal to the reflected ray angle. So these four simple rules which we study in the elementary level, I explained here. In my next video of the spherical mirror, I will explain the basic equation and the ray diagram, that if the object is somewhere, then where the image will be formed. So then, until then, I would like to say goodbye and see you in the next video. Thank you very much.